Hi, welcome back to ChemTube channel. I'm Jaku Wong. Today we are going to look at Melaka trial paper 3. Let's start. Okay, question number 1. A student wants to prepare a soluble salt through the neutralization reaction between the acid and the alkaline. So volume of hydrochloric acid is 2 mole per cubic decimeter needed to neutralize 25 cubic centimeter of sodium hydroxide solution. 2 mole per cubic decimeter is determined by titration method. Okay, so using the phenolphthalein as an indicator. So the titration is repeated twice, means total you do for 3 times. The result is shown in the table 1.1 and 1.2. Okay, so now I will show you the videos how do we do the titration method. Okay.
Take the burette initial reading. Record it to 2 decimal places. For example, 10.90 cubic centimeter. The initial reading does not need to be at 0. Place 25 cubic centimeter of sodium hydroxide solution in a clean conical flask. Add 3 drops of phenolphthalein. Note the color changes. Place the conical flask on a white tile so that any color changes can be observed. Then place it under the burette. Carefully turning the stopcock, add small amounts of hydrochloric acid to the flask. Continuously swirl the flask to completely mix the 2 solutions. Continue additions until 1 drop of titrating solution causes a color change which lasts for at least 30 seconds. This is the end point of the titration. Record the final volume reading of the burette in your notebook and calculate the total volume of titrating solution that has been added.
So this is how we do the titration method. If you have any questions, you can leave in a comment. Okay, now A1, record the burette reading in the space provided in table 1.1 on the page 3 and 1.2 in the page 4. So 3 marks. So let's see the questions. Okay, so it's under measuring using numbers. So this is the initial burette reading. Okay, so you can see there is no unit given. So meaning that in your data later you need to put in the unit for it. So burette reading will be under volume cubic centimeter. So when we do the readings, remember, okay, we will look into the center here. So we read the numbers here. Okay, so this is 0, this is 1. So here each column is 0.10. So 1, 2, 3. So meaning that this is 0.30 cubic centimeter. So final reading will be 25.30. This is for set 1. Okay. Then set 2. Let's see again. 25.30. So this is 49.80 cubic centimeter. Okay, and set number 3, this is 0.50, then this is 25.00 cubic centimeter. So remember, all the readings for the burette must be put or correct to 2 decimal places, including 0. If the initial reading is 0, so you have to put 0.00 cubic centimeter. So this is for score 3. Okay, next, construct a table to record the initial burette readings, final burette readings, and the volume of hydrochloric acid used in the set 1, 2, and 3. So you need to record 3 information here: initial burette readings, final burette readings, and then volume of hydrochloric acid used. So meaning that all the 3 information you have to put into a table. So suggest the answer. Okay, so set 1, 2, 3 initial burette reading. Okay, unit you put after the label here. Final burette reading, and then volume of hydrochloric acid. So you put in the information. So volume of the acid used will be the final reading minus the initial reading. So you get the correct volume of the acid hydrochloric acid use. Okay, so avoid using the write the unit under the data. So avoid using using this method. Okay, we will write it like this. So this is for score 3. For score 2, okay, missing unit. Okay, no unit is returned, so -1 mark. So this is for score 2. For score 1, missing the volume of the hydrochloric acid. Okay, so score 1. Okay. Next, calculate the average volume of the hydrochloric acid used to neutralize the sodium hydroxide. Okay, so here actually we do for 3 times. Okay, so we just take the average volume of the hydrochloric acid used. So 25 plus 24.5, then 24.5 divided by 3. So you get 24.67 cubic centimeter. Unit must be written, so score 3. Okay. Now predict the color change of the sodium hydroxide at the end point of the titration at reach. Okay, so color change, here you have to mention the initial color, then what is the final color. Okay, so just now from the video just now, you also can observe the color change from pink to colorless. Okay, pink to colorless. So score 3. For score 2, without mention the initial color, so just mention turns to colorless, so it's score 2. Score 1, not mention any color change, just mention the color is changed, so do not specify the color change from pink to colorless. Okay. Now diagram 1.3 shows 3 sets of experiment to prepare the soluble salt through the reaction between the acid and the metal oxide. Okay, so first one is the copper 2 oxide react with the sulfuric acid. Then mixture is filtered and heated until saturated. Okay, then you will get the blue solution. Okay, now I show you the video on the reaction. Okay, so first add the sulfuric acid into the copper 2 oxide, or vice versa. You need to stir it. Okay, then filter first to remove the unreacted. Okay, so you get the blue solution, then you heat until saturated. Okay, and then actually you'll get the blue salt crystal, blue color. Okay, but here just mention the blue solution only. Okay, so this is for set number 1. Okay, how about set number 2? Set number 2 is a magnesium oxide react with the sulfuric acid. So again, so actually you will get the colorless solution. Means the solution produced is colorless. Okay, another video here. No. See. Okay, so magnesium oxide react with the sulfuric acid. Okay, so it forms a magnesium sulfate is a soluble salt actually. So it forms a colorless solution. Okay, then actually if you want to heat it until saturated and then filter it, and then you get the white solid. Okay, white solid. Okay, next one is another one is iron 2 oxide. Okay, iron 2 oxide react with the sulfuric acid. So actually if you heat it, and then you will get the green solution like this. Okay, like this. Okay, so there are 3 experiments here. Okay, now okay, for this experiment, okay, what is the manipulated variable? So it's the metal oxide used, or you list out all the metal oxide, carbon 2 oxide, magnesium oxide, or iron 2 oxide. Also correct, Then responding variable, okay, soluble salt, or carbon 2 sulfate, magnesium sulfate and then iron 2 sulfate are produced. Okay, and constant variable sulfuric acid, we fix the sulfuric acid as a constant variable, so 3 marks. Then hypothesis. Okay, so just now see, this is our MV, this is our RV. So our hypothesis suggested answer. Okay, when different metal oxide react with sulfuric acid, then different soluble salt will produce. Okay, this is hypothesis for 3 marks. For 2 marks, when different metal oxide react with sulfuric acid, then different salt will produce. Okay, not mention the soluble salt. Okay, for score 1, when for score 2 again, when different metal oxide used, the different soluble salt will produce. Okay, use not mention react with the sulfuric acid. Okay, for score 2. Then another one, different soluble salt will form when different metal oxide react with sulfuric acid. So this one, it will be reverse MV and RV. So reverse already, so score 2. Okay, score 1, metal oxide react with the acid to form the salt. Metal oxide form the soluble salt. Okay, so okay, score 1. Okay, next, state 1 observation and 1 related inference for each set of the experiment. For set number 1 is forms a blue solution. Alright, blue solution is formed. So the inference, the blue solution actually is a copper 2 sulfate produced. Okay, next one, set number 2, colorless solution. So colorless solution actually is the magnesium sulfate form. Okay, then finally is green solution form is iron 2 sulfate solution form. Iron 2 sulfate, salt, soluble salt. So this one, observation 3 marks, then inference 3 marks. So it's 3 plus 3. Okay, so total is 6 marks. Okay, so operational definition for soluble salt. Okay, soluble salt in set 1. Set 1. So operational definition is what should be done and then what should be observed. Okay, so when carbon 2 oxide is put into sulfuric acid, okay, this is what you do. Then observation, blue solution is formed. Okay, so this is a soluble salt. Or when carbon 2 oxide is put into the sulfuric acid, black solid dissolve, also accepted. Okay, because carbon 2 oxide is black color, so it dissolves. Okay, score 1. Okay, metal oxide or carbon 2 oxide react with acid. Okay, so score 1. So if you put any one of these, what you do and what observe, then you get score 2. Score 2. Okay, next, if saturated solution is left to cool to room temperature under running tap of water using the ice cube, state the relationship between the temperature and the time taken. Okay, for the salt crystals to form. So the lower the temperature, the shorter the time taken to form the crystal. Okay, because when the temperature is very high, the time taken to form the crystal will be longer. Score 2, temperature affect the time taken. Okay, not mentioning how is the relationship. And then decrease or changes will be score 1. Score 1. Okay, next, classify the soluble salt based on the type of preparation of the reaction of the salts. Okay, so classify. Neutralization between acid and alkali will be sodium, potassium, and ammonium. So here we have potassium and ammonium. So potassium, ammonium, sulfate, and nitrate. Okay, then react with acid with the metal oxide. Beside these three, sodium, potassium, and ammonium salt. So be carbon 2 chloride and then magnesium chloride. So score 3. If totally reverse, will be score 1. Okay. Question number 2, experimenting. Okay, photograph 2.1 shows the different size of puree bread that is not mixed with yeast and puree bread that has been mixed with yeast. Okay, one without yeast, one with yeast. Okay. Then yeast contains the zymes enzyme which act as a catalyst. So to speed up the formation of the air spaces in the dough, causing the pureed bread to expand. Without yeast, the puree bread will look flat. Huh? Okay, so next, okay, referring to the above situation, plan a laboratory experiment to study the effect of catalyst on the rate of reaction. Huh? Okay, so your planning should include the following aspects: problem statement, okay, until tabulation of data. So total is 70 marks. Okay, for your information, okay, normally in this question, you will be given a situation like this. So in your experiment later, okay, normally don't. It is not advised to use the experiment using the situation like this case is the bread. So don't use the bread in the lab because normally it's very difficult for us to do the bread experiment in the lab. So normally you need to do the experiment based on the title, like say catalyst. So we use the one in the SPM syllabus. Okay, so it's using the hydrogen peroxide experiment to determines the effect of the catalyst on the rate of reaction. So now I show you the experiments or on the on these experiments on the title of effect of catalyst on the rate of reaction. So add the hydrogen peroxide into the test tubes. Then add in a little bit manganese oxide as the catalyst. So you see. Okay, insert the glowing wooden splinter and then it will relighted the or lights up the glowing wooden splinter. Meaning if we do not put in any manganese oxide as a catalyst, the glowing wooden splinter it won't be able to light up. Okay, so first problem statement. Okay, for score 3, how does a catalyst or manganese oxide affect the rate of reaction between the hydrogen peroxide? Okay, so you can add in decomposition of hydrogen peroxide. Then number 2, how does a catalyst affect the reaction? Or score 1, to investigate the effect of catalyst on the reaction. So score 1. Okay, next, variables or manipulated variable, presence of catalyst or presence of manganese oxide. Responding variable, okay, so this is rate of reaction, so just write rate of reaction, or you can write decomposition rate of hydrogen peroxide. Fixed variable, we use the mass of the manganese oxide used, or temperature or volume of hydrogen peroxide used. Okay. Hypothesis, okay, the presence of catalyst increase the rate of reaction. Okay, for score 3. Score 2, presence of catalyst speed up the rate of reaction. Okay. Score 1, catalyst affects the rate of reaction. So material use. Okay, number 1 is hydrogen peroxide solution. Number 2, manganese oxide powder as the catalyst. Apparatus use. Okay, we use a measuring cylinder, test tubes, test tube rack, and then wooden splinter. So 2 materials, 4 apparatus. Spatula, 5 is spatula. So I need 5 spatula at 6 electronic balance. So meaning that for score 3 you need 2 material and then 6 apparatus. So total is score 3. For score 2, material 1 and 2, then apparatus 2, 3, 4 and 5. Score 1, 1, 2, material, and then apparatus 2 and 4. Okay, 2 and 4. Okay, procedure. Put 20 volume of 5 cubic centimeter of hydrogen peroxide solution into a test tube 1 and test tube 2. Okay, place 2 test tube in the test tube rack there. Then add 0.5 gram of manganese 4 oxide into test tube 2. So test tube 1 without the catalyst. Then place a glowing wooden splinter into the mouth of the both test tubes quickly. Then observe and record the changes that occur to the wooden splinter, whether it is lights up or not. Okay, so this is for score 3, 5 steps. For score 2, step 1, 3 and 1, 3, 4, 5. So meaning that miss out the step number 2 for score 2. Score number 1 is 1, 3 and 4. Okay, for score 1. Finally, tabulation of data must be put into a table. So, suggested answer: presence of catalyst, with catalyst, without catalyst, and with catalyst manganese 4 oxide. So, observation: leave it empty because you are planning the experiment. This is for score 2, maximum. Then score 1, without mentioning the presence of manganese 4 oxide. Okay. So it got the title and then the observation. This is for score 1. Okay, so that's all for the Melaka trial paper 3. So if you have any question, you can leave at the comment below. Do like, share and share this video with your friends. Okay, thank you very much.